everyone, welcome to JGK Masterclass. Guys, in today's video, we will learn about the principle and instrumentation of proton NMR. I have uploaded many videos on proton NMR. You can watch the respective topics. I will share the links in the description box. And in this particular video, we'll be discussing the question related to the instrumentation and principle, which is from the MSc Chemistry from BCU University. So the question is, give an account of the principle and instrumentation of an 7T NMR instrument. T for Tesla here. 7 Tesla is the magnetic field. So first we will discuss the principle. Working principle of NMR is based on the spins of atomic nuclei. So here in NMR we talk about the spins of the atomic nuclei. So how to find which atoms are or which nuclei are NMR active? So nuclei with odd mass, odd atomic number or both will have the nuclear spin and it will behave like a magnet, and so it will possess a magnetic moment. In the presence of magnetic field, the nucleus will spin. Okay, spinning will start and it will show the NMR activity. So examples for such nuclei are, you can see here 1H1, the atomic mass and atomic number both are odd here. 1H2, here the atomic number is odd. Okay, so option is either atomic number or odd mass or both. So you can see here 6C carbon, 6 is here atomic mass is odd number, 7N14, here you have atomic number odd. So basically one of the figures should be odd here or both can be odd. If both are even, it will be NMR inactive. So if we talk about carbon 6, carbon 12, that is NMR inactive because both are even there. Okay, that's why we study 6, carbon 13. Similarly, you can notice here 8O17. 17 is odd here. If you talk about the normal mass of our oxygen is 16. 8O16 will be NMR inactive because both are even. So, and you have 9F19 fluorine, both are odd. So, all these nuclei are NMR active and will behave like a magnet and will possess a nuclear spin. So, this is the principle of NMR, and it will have the spin angular momentum value, which is represented by capital I, and I have prepared a video on that. You can watch the video on spin angular momentum and spin moment values 0 or it should be greater than 1. Now instrumentation. The basic feature of instrumentation needs three components. One is magnet, other is radio frequency source and a detection system. These three very basic system: magnet, radio frequency source and the detection system. So we'll have a diagram here which is kind of a block diagram. You can say you have a radio frequency source and your sample tube is surrounded by a magnet. Here the magnet is 7 Tesla. Okay, this is magnetic field which is fixed at 7 Tesla, and this is the spinning will start in the presence of this magnet and it will be detected by the detector and amplified and display on the recorder. So very basic system. Here you can notice what are the steps involved. The sample will be irradiated at a fixed field with a strong pulse of radio frequency. Energy containing all the frequency over the proton range. So here we are keeping the this magnetic field static, which is for example 7 Tesla, and we will irradiate the sample with the range of radio frequency so that the all respective protons in that range will absorb the respective range, respective value, and will show and appear as a peak. Okay, so for 7 Tesla it is around 300 megahertz instrument. You can see the same statement is written here that the proton in each environment will absorb an appropriate their appropriate frequency from the pulse, and these frequencies couple to give beats, and these beats are called interferogram in the time domain. So you can notice here in this diagram you can see the beats. These beats are called the interferogram pattern, which is a time domain signal. And in this form, you cannot read the spectrum. So therefore, it has to convert, the time domain signal has to convert into the frequency domain signal, which is a human readable form. So here one can, so the instrument is only converting the time domain signal to frequency domain signal by using FT-NMR, which is called Fourier transform NMR. So here the role of this is the time, it converts the time domain signal into the frequency domain signal, which is a human readable form, and it will be digitized on the computer, and each individual frequency will be identified by its interference pattern. So in this way, you can read the spectrum for your unknown molecule. And regarding the NMR instrumentation, if you get any question, so you can write down and draw these two diagrams, where one is a block diagram related to the radio frequency source, magnet and detector. Other is this interference pattern, time domain signal and frequency domain signal. So these two diagrams are important for instrumentation, and a few statements to explain it. I hope you understood the instrumentation and principle of NMR. If you have any doubt in any topic of spectroscopy or any other topic, you let me know in the comment section. I'll try to prepare a video on it. Happy learning.